back to polygons. If you remember, way back in semester one, let's think about the three things that make of a or a shape, a polygon. Well, one thing, it has to have three or more sides. We start off with triangle, we go up to squares, and then we have pentagon, triangles, quadrilaterals, pentagons, and hexagons, and so on and so on. After that, all the sides, it has to be closed. None of the sides can be open or exposed whatsoever. And finally, it has to be flat and straight. Cannot be curvy whatsoever. So let's classify these. Three sides, we know this is a triangle. Four sides, well, that's a quadrilateral. Any four sides is a quadrilateral. Five sides is a pentagon. Six sides is a hexagon. Okay. A convex octagon. Let's see. Remember, an octagon has 8 sides, and convex means all the sides are pointing out. There's no caves. There's no divots. So 1, 2, 3, 4, 5, 6, 7, 8. That is a convex octagon. A concave, keyword being cave, heptagon. Heptagon is a 7-sided shape. That means we need, and a cave, we kind of have to make a little cave, a little dent in our heptagon with 7 sides. So 1, 2, here's a dent, 2, 3, 4, 5, 6, 7. This is a concave, an example of a concave heptagon. Next, a polygon where all sides are congruent. Well, all sides congruent is considered equilateral. Lateral being the key word. Lateral is on all sides. So for an example of that, a square would be a good example. All the sides are the same and they are equal. A polygon where all the angles are congruent is called equiangular. Angular being the key word there. And of course, an example of that could also be, an equilateral triangle, or, a square is also one of those. But equiangular, actually, a rectangle could be one, because all of the angles are technically the same. They're all 90 degrees. They're all 90 degrees. That means all the angles are the same. A polygon is convex, equilateral, and equiangular. We call these regular. A regular polygon is where it's everything. It is all pointing out. It is equilateral and equiangular. Okay, let's go down here and let's try some of this. Is it concave or convex? Well, this one is making a cave, so it is a concave. Is it equilateral, equiangular, regular, or neither? This is neither. This does not have anything equal. Number 2, it is not making a cave, so it is a convex. It is vexing out. None of the angles are the same, but I see these tick marks on the sides, meaning all the sides are the same. So this is equilateral. Let's go back to number 1. Let's see how many sides number 1 has. It has 1, 2, 3, 4, 5. It has 5 sides. So this is a pentagon. it is, and this is a convex equilateral. It has 4 sides, so this is actually a quadrilateral too. Let's see here. This next one, wait. Oh, try it. Is the shape a polygon? Oh, yes, it is a polygon also. Number 2, it is a polygon. Number 3, it is a polygon and all the sides are the same, so it is equilateral. It is also making a cave, so it is concave. And it has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is a pentagon. Let's go and try next one. Oh, this one is definitely a polygon. It has none of the sides are all the same, but all the angles are the same. So it's equal angular. Equal angular. Angular. And then let's see here. Let's count how many. There's 1, 2, 3, 4, 5, 6. So this is a hexagon because it has 6 sides. And it is also convex because all of the sides are pointing out. See here. This is 1, 2, 3, 4. This is 4 sides. It doesn't have any tick marks. So, but it is, yes, a polygon. It is a quadrilateral. It is neither like equiangular or equilateral, but it is a quadrilateral. And it is also convex because it is flexing out. This one, ooh, it is, yes, it's a polygon. And it is actually a regular polygon because it is both equal angular and equilateral, and it is convex, and it has 1, 2, 3, but I mean regular, that's always assumed convex anyways, but 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Make sure I counted right. 1, 2, 3, 4, 5, 6, 7. So 7, so it's a heptagon. Okay. Try this out. These are regular polygons. Find x. The wonderful thing about regular polygons is they must be all equal. So x plus 9 must equal 15. Subtract 9 to both sides. X must then equal 6. Number 2, 2x must equal 120. Divide both sides by 2. X must equal 60. Finally, the segment formed by connected to the 2 non-adjacent vertices of a polygon is called a diagonal. Okay, try it out. Draw and name the polygon below. Draw the diagonals and name the diagonals. So let's say here, regular pentagon. Okay, so that is 5 sides. They have to all be kind of the same angle and lengthwise. I'm not the best drawing, but I'll try it. So basically all of them have to be the same. So 1, 2, 3, 4, 5, all they have to be the same. All the angles have to be the same. This is a regular pentagon. And I'm going to draw the diagonals. I'm going to call these, first I'm going to label these A, B, C, D, E. So here, I'm going to just draw, connect all the corners together. And if I label my diagonals. Here, diagonals. There is an AC, AD, BD, BE, C, well, I got CE, should get D twice. There's 1, 2, 3, 4, should be 5 diagonals, I think. Where is that? 6? Should have A twice, should have B twice, should have C twice, should have D twice, and should have E twice. There we go, all of our diagonals. And if I name this, I'm just gonna name this AB, pentagon A, B, C, D, and E, and that's how we would name it. Equilateral hexagon. A hexagon has 6 even sides, so this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Assume all the sides are the same. All the angles are the same. This is a regular hexagon. And we're just gonna, I'll label these something different. So let's call this L, M, N, O, P, and Q. So we're just gonna connect each one to each other. And there we go. And let's try to name all, well, the easiest ones, just to name it. We'll call this L, M, N, O, P, and Q. And the diagonals. There should be, let's count them. There should be 3 for each one, so 3 times 6, maybe. We should have 9. So let's start with L. So there's a L, LN, LO. Wait, erase that. LO, LP. We have a MO, MP, MQ, and we have a N. So we already have L and N, NQ, NQ, and an NP. And then we have a P. We already did all those. I think we have the Q's. There's 1, 2, 3, 4, 5, 6, 7, 8. We are missing one. So let's see here. M, NP, NQ, and L. Okay. O, M, got that. O, L, got that. O, Q, OQ. Here we go. And then we should have P's twice. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. Well, there we have it. All of our diagonals of our polygon.